Okay, science of mathematics. Let's talk about area for a minute. We've got, actually let's start off talking about line. If we have a line going this way, we can say this is positive and this is negative. If we have a line going orthogonal or sideways to that, oops, we have two edges of a border. We can see our origin is up here. This is where we're starting from. Okay. Now, if we pick a unit, I'm going to call it a Fred. And I'm going to say my Fred is about a ½ inch. Makes it easy with a ruler. And I'm going to set up I'm just going to mark, let's go 3/4 inches. I'm going to mark my Freds like so. Going down the ruler. Next Fred would be right there, like so. And we just mark, and we effectively make a ruler in Freds going out as far as we care to, or until we run out of paper. There we go. We can now measure Freds out. This, of course, being a ruler, we're marking a full unit. So this is our 1 Fred, 2 Freds, 3 Freds, 4 Freds, 5 Freds. I know, it's kind of hard to see. 6 Freds, 7, 8, 9, 10, 11, 12, 13, 14, and 15 Freds out that direction. Great, we can measure one direction. Now, if we go orthogonal, or at 90 degrees, and we draw Freds the other direction, then we have another ruler going this way, and it's also in Freds. Let's see here. Like so. This is also 1 Fred, and 2 Freds, and 3 Freds, and 4 Freds, 5, 6, 7, 8, 9, and 10 Freds going that direction. So now we can tell how far away we are from our origin in 2 different directions. Now, when we have a direction in one direction and then a direction in the other, or one direction and then an orthogonal or 90-degree direction going another way, and we have 2 distances, we call that area. And if we draw some lines, I'm going to really quickly draw some lines down the other side so I can make sure my lines stay straight. Like so. And if I mess up on this, it will look really funny, so I hope I don't. But there you go. Alright. So if I go this direction, and I make some lines, or if I make them a little easier to see, I can go the other direction. Say, oh, that's what he's doing. I'm just going to make a bunch of lines. I'm making just a bunch of lines this way. It's almost like watching paint dry. Alright, so we've got some. We'll finish up the rest of them in a little bit. And now I want to make some marks going the other direction. So I'm going to go like so, over here. And I'm just roughly counting out ¾ for each of these marks, because that's how much my fret is. And then I go across with my straight edge. Right now, I end up with a bunch of squares. Now, when we have two directions that are not the same, and we combine those, we get area. And area is not measured in freds anymore, because fred is just a distance. If we take fred times fred, then that makes a square fred. And a square fred is different than a fred, because a fred is a measure of distance. A square fred is a measure of area. And so we're making a bunch of square freds. Fred is such a square. Man, he's just square. So now we can line up our things, and we can draw a few more freds here. Oops. This ends up being, we could like pretend these were tiles. Sometimes you see a bunch of tiles in a bathroom or a kitchen, and they make a bunch of squares. So squares are everywhere. But it also covers how much area or how much surface we have. And that can be a very important thing when you're measuring stuff. So now I have a bunch of squares, bunch of square freds. So what all is this for? Well, if I want to count how many freds, I'm going to use a couple pieces of paper like this to cover up the freds I don't want to concern myself with. And I say, right here, how many square freds do I have? How many squares do I have? And I can count them. That looks like one. One square. Okay? Now, I'm going to keep this in a rectangle. And say, how many squares? Got one and two. Okay, so I got 2 squares. And 3 squares. And 4 squares. Well, I think you get the idea. Now, on the next row, I'm going to cut it back down here, so I just have these squares here in this rectangle. How many squares? Well, I've got 2. Let's see, 1, 2, 3, 4, and 6, 8, and oh, I ran too far. So I've got 5 and 10. I think you get the idea. See, how many squares do I have here? We've got 3 and 6 and 9. If I go down, we've got 4 and 5 and 6. Okay. Now, all we're doing here is counting the squares and writing down how many. And in the process, we are creating what's called a multiplication table. And some of you already knew that, but it has some patterns, some properties I want us to observe. So, in the multiplication table, we can observe some things. For starters, look, we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So, regardless of which order we multiply, we can either say, this is our x goes this direction, and our y goes this one. So, if we write that out for a minute, we can say, okay, I have my directions here. This is going to be my x direction. This is going to be my y direction. And if I have x times y, that's going to be the same as y times x. This is called a reflexive identity because it reflects. It's like a mirror. And on our multiplication table, it's like a mirror. If I took a mirror, and maybe I'll get one of these days, held it up like that, I would see the reflection of the other side here on my paper. So, this is a property, or I could also write this is my A and this is my B, and A times B is equal to B times A. So, it doesn't matter what order I multiply in. So we can see that. Cool. First secret of the multiplication table. And this is an 8. Now, if we look down the row, we've got 16 and 25 and 36. And these, each of them, make perfect squares. So that's 1, and that's 2, that's 4. 2 times 2, 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And these are when a number is times itself. And when we have a number times itself, we have an A times an A. That's equal to A times itself twice. Okay, so this is just a different way of writing it down. I have 2 A's here, so I have a 2 up here. If I had A times A times A, that would be A cubed. A times A times A times A would be equal to A to the 4th, and so on and so forth. A single A is just equal to A to the 1st. I've just multiplied it by itself one time. Okay? So that's another shorthand notation for when I'm adding things together. Now, if I were to add them instead, A plus A, then I've got 2 A's. And A plus A plus A is equal to 3 A's. A plus A plus A plus A is equal to 4 A's. So, this is just, when you add them together, you end up counting. When you square them, if you're adding, the 2 goes in front, and then that's 2 times A. If you're multiplying, this is called an exponent. I think I got that word right. So x are powers. This is the a to the first power to the second power. It's multiplied by itself that many times. And that's just a shorthand notation. Because mathematicians are lazy, they don't like to write it this way when they can write it that way because it's so much shorter. Alright, so I've got the multiplication table. And the multiplication table has a lot of secrets in it. And that is we've discovered a couple of them first so far. Reflexive. Reflexive property. We've got powers, just in a notation and how we're looking at it. And then we have some other things. But first, I'm going to go ahead and fill in this multiplication table and see you next time.